Now see Newton's third law of motion. To every action there is equal and opposite reaction. See here, if you have got the two bodies like this, I have taken the body 1 and this is the body 2. This is body A and this is B. Both are moving towards each other. They collide for a moment like this. When they touch to each other, on that time A applies force on this and B applies force on A. So, force applied by B on A and force applied by A on B, that we can write FAB. Force applied by A on B and force applied by B on A, that is FBA. These two forces are equal in magnitude but opposite in direction. These two forces are acting on the two different bodies. They are not acting on the same body, and also the forces always occur in the pairs. So, and they are action and reaction pair. There is no cause and effect relation because both the forces act at the same time on both the bodies. Anyone can be taken as action and anyone can be taken as reaction. So, this is the Newton's third law of motion. Now, see illustrations of Newton's third law of motion, we are actually taking examples. Suppose you have taken this is a tabletop, and suppose any object or the book suppose is lying on this like this is here. So, due to gravity or you can say gravitational pull, the book is being pulled downside, that is its weight. So, book is applying force on the top of the table equal to its weight, and at the same time the table is applying force on the book, that is upside, that is taken as R. This is called normal reaction. So, when the force or the book applies force on the table, table applies force on the book. That is an example of action and reaction pair. Both the forces acting are on the two different bodies, like R is acting on the book and W is acting on the table. Another example we can take walking. Now, see here, when you walk on the road, what happen actually? You push the ground by your feet downward and you get the reaction from the ground, and then we take the component. Suppose you are pushing the ground downward like this with the force here F, you get the reaction to this side R, and now then we take two components of this R, this is theta, suppose R cos theta, and this we take as R sin theta, and weight is acting downside. So, actually we have taken here the force applied by the man while walking on the ground, that is F, and he is getting the reaction R, and we are taking two components of this R cos theta and R sin theta, and weight W is acting vertically downward. So, see here, due to component of the reaction R cos theta, man is able to walk. So, drawing of the forces acting on the system, first you have to choose here the system. Acting on the system is actually also known as free body diagram. So, we have drawn actually this is a free body diagram here. So, man is pushing the ground, ground is applying force on the man this side and then its component and all that. So, this is the another example of the Newton's third law of motion. Similarly, we can take another example like recoil of gun. Recoil of gun, what happens? When you fire bullets by the gun, what happens? Bullet moves forward in forward direction and gun moves in the backward direction. This is action and reaction. As the bullet moves in forward direction, it applies force on the gun and the gun moves in the backward direction. That is called a recoiling of the gun. Similarly, in case of the rockets, gases are burnt. When the gases are burning, these gases are coming down and they apply the due to the reaction of these gases, and the rocket moves upward.